BISP Solutions, myself Ashwin, and I work as a technical consultant, and BISP Solutions is a tech company provide technological solutions across the world. Now our today's session is all about Pytorch classification. See, in our last few sessions we have seen the working, but today I'm going to explain you exactly how this binary classification, what is this, how this Pytorch works in binary classification, and what is the mechanism behind this, and in what conditions it is used. Right, today we will focus on the scenario, right, scenarios in which it is used, or we can say use cases. We are focusing on use cases, and remaining technical part I will show you as usual, as we have seen in our last few sessions also. Right, so let's start. So what is this classification problem? See, the main thing is that on digital data we can calculate. We have seen how Pytorch works on digital data, right? But on technical, I mean to say image data, how it needs to process. So that is what we are going to see here. Suppose you can see here is this email. Now see, there are three types of classifications, right? Three types of classifications. One is the binary classification. Let me make this bigger. Now one is binary classification. Now where binary classification means what exactly, where the condition is yes or no, right? The result would be yes or no. Multi-class classification means that I have given you an image and I ask you that tell me that the person, or we can say the animal shown in the image, whether it is a dog or it's a cat or the rat. This type of, look at this. Now see here, so that is called multi-class. Multi-classification means when the answer is one out of the three given options. I will give you the image, it's a combined image, mixed image. Now we will focus in these two, binary and the multi-class. So now you see here binary classification. Now binary classification means, suppose if I ask you exactly whether the dog is present in that image, yes or no. Secondly, tell me the name of that animal, which either one of these, either dog, cat, bus or plant. What is that? So this is called multi-class classification. Now if you see here, first of all the input is given to the image input is given to the machine. Now what machine will do, machine will first take that input and convert it into the tensor. First of all it will convert it into the pixel, and then it will put the either 1 or 3, that is the color range, right? Color. If it's a grayscale, then it will use 1, and if it is a multicolored image, then it will use 3. Then after the processing, after some layer of processing, it will show you that okay, out of these three, whichever is the output, right? Then if you see here how the tensor works, let me show you this. Here, look at this. This is the complete mechanism of the tensor, that how it works. First of all, see, torch vision, transform, torch .utils, dataset, and torch.utils, data loader. These are the libraries that we need to bring. Then build or pick a pre-trained model. Now see, when you will enter that image, it will be first converted into the tensor only, right? So torch.tensor. Now after complete converted into tensor, then what will happen? Let me show you this here. Look at this. First of all it will be converted into tensor. Then second part is here, you will see the tensor, torch.tensor model. The model is created. After the creation of model, you will see the binary cross entropy with logistic loss, right? That function is used here. After that, calculate the accuracy. Now we will calculate exactly the accuracy. What type of accuracy is that? After that, if you see, I will show you the technical point also. I will show you the running program also, right? So don't worry about that. Then we will calculate the accuracy. After that, we will fit the model into epochs. Now if you see here, we have taken 1000 epochs, that is called 1000 repetitions, right? So repetitions, after 1000 repetition, we will see the prediction now. So whatever the predicted data is there, that tensor is, that predicted data is coming. Then we will use a helper function here, see, right? Actually this is not needed, this is just for boundary, right? I will show you the boundary, this boundary line, that is for that. Actually it's not that much useful. Now if you see here, we will plot that data. Now while plotting that data, we will do the same process. If you see here, decision boundary, that is why it is used, the decision boundary related, right? So look at this, plot decision boundary. So this, you can see here the boundary line, right? That is why it is used. After that we plot the data. After plotting the data, you will see here that how the data is scattered, right? This is the train and this is the test, right? Almost it looks the same, right? So this is how the process is done. Similarly, and also I recommend you to watch, after watching this video, you watch this twice and then see my previous 3 days videos, right, where we have matched the images, right? Then that concept will be clear to you, right? Okay, now multi-class classification. Now let's see this multi-class classification. Let me go here also first, right? Now see here, first complete this PPT. Now see .optim, torch neural network, then the module, then the models. Everything is done at this phase, right? Then we see here again this pre-built model, pre-trained model. We put the input into this pre-trained model and then fit the model to the data and make a prediction. After the prediction, with the help of torch matrix, look at this, evaluate the model, then improve through experimentation, that is epochs. That is what we were using, epochs, that means the repetition. Then torch.utils.tensor board. After that, save and reload your trained model. That is the complete procedure. Now if you see here, improving a model, now let me show you this. Look at this. Now if you see improving a model, how the model is improved. So we put the out features and in features, right? Out features means that is we put some data value at the time of improvement, and after that we use this ReLU function, right? So these functions makes the things makes the image what we say, the process much better. Now if you see here, this is linear data and this is non-linear data. This is ReLU activation. We will see this in our practical part. Now if I show you, just a second here. So first is loss. Construct or import a pre-trained model relevant to your problem, then prepare the loss function, that is optimizer and training loop. Then the loss optimizer, what is this loss? So how wrong your model's prediction are compared to the truth labels. You want to minimize this, right? Secondly, optimizer, your how your model should update its internal pattern to better its predictions, right? Then fit the model to the training data so it can discover patterns. Then you will see the epochs, how many times the model will go through all the training example. See, epochs means, suppose if a child is studying in 5th standard, then daily how many hours he do study, right? You can compare it like this. Suppose a child is studying daily 10 hours, so definitely he will score high, right? So that is the process. After that, you will see fourth is evaluate the model on the test data. How reliable are our models on the test data? How reliable are our models predictions, right? So we will evaluate that model. That is why evaluate function is there, test function is there, loss function is there, optimizer function is there, and the epochs. The complete mechanism works. So let's come to our practical part. Let me show you step by step, right? So if I open this, right, now see here, first let me create one new IPython file, interactive Python, right, Python notebook, that is IPython file, and now I will create, it will take a little time. So Pytorch, right, and I will rename it. Okay, I have already written this some notepad here, so we will follow this notepad first. So first of all we will see binary classification here, right, and you all know that for this we need to, and then we will hash, that's it. I will hit the enter button. Binary classification, this is our heading. Now see here, make the plot data. Now first of all what I need to do is, now see how these lines are written. First of all, import matplotlib pyplot as plt, right, as plt is our variable from sklearn datasets. Now see, we are calling the dataset like mark circles, that means it's a non-linear data, it's circle data, and we have taken 500 samples, right? Look at this, 500, right? We have written here, I think it should be 500, right? Now if you see here, now I will hit, first of all the library is called here, and now it is working here, plt.scatter, right? So it is still working. We need to wait for 2-3 seconds. Now look at this, this is what the plot is created. Okay, now if you see here, you can see all the data is created. Why? Because we have used make circles, right? So now if I now see here, yes, so what we have done, we have used the numpy also, right? Here we have already, we have to call this, I think, numpy. Okay, no problem. From numpy type torch float, right, turn data into tensors. So here we are converting data into tensor first, then split into train test. So this is our standard procedure. First of all, get the data, then convert that to the tensor, and then training the data, right? So I'm again hitting the enter button. It taking time, just wait for 2-3 seconds. We will, then after that what we will do, look at this, the data is converted into tensor, and this tensor data is shown to you, right? Now what next, let me show you that also. Now what is this? Build model with non-linear activation function. Now see, we are talking about the circle, right? So that is why we have to build model with a non-linear activation function from torch.import torch import neural network. Circle model v2, right? So circle model we have given out feature 10, then in feature, then again out feature 10, then these are the two layers that we call as neural network layer, right? Just take a daily life example. Suppose candidates are coming to interview, right? So my senior authority, they say that okay, take the interview and select best person. So what I will do, first of all I will ask the simple general technical question, then all the 10 replied successfully, right? Now my another layer is, I will check they have received the education. If it is an English medium, that means they might be good in English. So this is our first layer of first neural network layer. Then I will see their attitude, whether he can work here for a long time, because many times what happens, the candidate learns in the company and then immediately switch. So that thing should not happen. So that is our second layer of neural network. You can consider it like that way, right? So same thing is here. This is layer 1, layer 2, right? So we come to the decision, right? Then we will see the forward method, and now I am hitting the enter button, right? So these are the layers, layer 1, layer 2 and the layer 3, right? My recommendation to you is just keep watching the video, and in first attempt you will understand 70%, in second attempt you will understand fully, right? So now if you see here, that here loss function equal to binary cross entropy with logistic loss, right? As GD and model 3. Model 3 is the, here you can see model 3 and then parameters, right? So here what we have done, we have optimized and the loss function is created. Now if you see here, now calculate accuracy of classification matrix. Now we need to calculate the accuracy also. As usual in our last few videos we have seen, we have to calculate the accuracy, that how accurate this function is, right? Because we need to test that thing also. So accuracy function is now calculated. Here accuracy function is fixed. You just need to put your data only that in that. You can see here, okay, return ACC. Okay, now what will happen here, if I show you fit the model. Now see, fitting the data into model, it's a very big function, and look at this. Now see one by one. Epochs means repetition. Just I have given you the example of a child. If the child which study 10 to 12 hours per day, definitely the chances of his scoring high, and the child which is studying only 2-3 hours per day, so how much he will score, that you decide, right? So in this way, epochs, if you take the epochs value as only 10 to 20, you will not get that type of accuracy, right? So this is how the more the epochs running, the more perfection you can achieve, right? So now train test data, right? Now put all device data target device, right? On target device we have to just put the data. Now epochs in range, epochs, that means from 0 to 999, right? After that you see here everything goes perfectly, and then you will see here, now I am going to hit the enter button. So what will happen here is, look at this, this epochs is running, and each time the accuracy is improving, right? Test accuracy, train accuracy, everything is improving. That after that what will happen, now we have to make the prediction. Now process, and then we will make the prediction, right? So prediction means after completing all the processes on the data, then we make the prediction. Now I am going to make the prediction here. Now this is the how the prediction data is received in the format of tensor, right? Again I will show you this also. Now see, download helper function. Now this helper function is just for plotting the boundary, that's it. No need, you if you don't focus on it, that's also okay, right? Now if you see here, plot the decision, right? Plot decision boundaries. This is important for you, so let's check it out. Now see what happens here. Here the plotting is done, plotting is being done. Now see, you can see this black color line, all the sides you can see here one boundary line is there. That is why it is plot decision boundary, right? So this is how the plot decision boundary works. Okay, now let's come here, see, and then since it's a non-linear function, right? So that is why it works like this. Now let's talk about the multi-class classification. Now multi-class classification means, so let me make it as markdown and then I will make it as hash, right? Okay, so multi-class classification, as we discussed in the earlier, again I am going to show you that suppose if I show you a photo and if I ask you that recognize that particular animal shown in the image, whether it's a dog, it's a cat, it's a bus, it's an aeroplane, anything, whatever. So since being a human, we can easily see, we can easily recall our memory, okay, this is a dog, and then all this happens within a fraction of second, that is a few picoseconds or nanoseconds, right? Context of technology. So in technology it's not that easy. We have written the big algorithms, right? So based on that we have to recognize. So how it is done, let me show you that also. Today we will see this. Okay, now X blob, Y blob we have already created. Turn data into tensor, again the same procedure, that is the tensor, right? Why I am repeating this again and again? Because you will automatically memorize all these things. So again the data is converted into tensors. Then once the tensor is created, then X blob, once the tensor is created, then X blob extend, X blob train, X blob test, Y blob train, Y blob test, train test split, right? In the bracket X blob, Y blob. Now what we will do here, we will see X blob train and train. Just look at this. Now see, you can see here it has separated the data and it has scattered the data also, right? So this is how the train and test data is showing. Okay, let me show you that also. Okay, so what I have done here, we have done a blob model. That means again we have created the blob. Now the linear, it's a linear data, right? Then again it's a non-linear data because it's a scattered data. Now I will show you here. You see, now see here, loss function. Now loss function will be created, cross entropy loss, right? Then optimizer torch.optim, SGD and sigmoid, that is sigmoid, and then model 4 parameters. Now what will happen next? Make prediction logits with model. Make prediction logits. So let me show you. At the end I will explain you the complete story, how it works. Now see here, Y logits, model 4 and perform softmax calculation. Okay, so Y prediction probabilities, right? So prediction probabilities are this. After this, if you see again, yes, now see here what I have done here. Now again the epoch process. Okay, now here you see X blob train, X blob test, Y blob train, Y blob test, and X blob train, comma Y blob train. So this is, we have to write down, and then we have to run the epochs, that is the repetition. We'll just hit. Now see, epochs run, and because of 100 and the stage is 10, so you can see divide percentile 10. That means after every 10 units it will calculate. Then what will happen here? Now see here, evaluation. So make predictions, that is okay, fine, but here we have done the evaluation also. Okay, so I am just hitting the enter button. Look at this, the data is converted into tensor, right? After this, then what I will do here, hit the enter button. Now see here, predictions tensor and label tensor, right? Then what I will do here next is I will just now see here, this is how it worked. It has separated the data in the boundaries. You can see here this, that is why that we have used that particular function, otherwise there is no need to use that. And here you will see every data having its own boundary line, right? So that is why that particular function was used. Okay, so let's move ahead. Now let me one more thing, let me show you. Okay, so today we have seen the binary and the multi-class classification technique is convert that into tensor, then calculating the loss, calculating the benefits, everything, right? Then after that running the epochs, and then that with the help of that epochs we come to a conclusion that what exactly we have seen in this. And about the scenario, the scenario is very simple. For example, if a camera, we have fitted the camera, and if we have written the program in such a way that just decide if it's a higher authority or that way. And suppose if then, so in this way fitting for longer. Okay, yeah. After that, if you see, this is a single data, linear data, and that is, so in this way we identify the image, or we recognize the image, whether it is a single person image or he is sitting inside a crowd, right? So that is also we can do it. So guys, today we have seen, today we are completing our session here only, right? We will complete our session here only, and on Monday, because tomorrow there won't be any bootcamp session. So if on Monday we will see some other topics, right? On Monday we will see some other topics and some other useful topics. So again, let's have a quick recap here. First of all, taking make circle, then second is convert to tensor, then train test, then model. After that model we will calculate the loss, right? Then accuracy function, then the manual seed of data, but that is not possible. After that you will see here the data is converted into this much accuracy. Okay, then you see here make predictions, then the prediction is done. After that, import request, that is for library boundary purpose, like look at this plot decision boundary, right? For boundary purpose we have done this, and then after that we plot the image. Similarly with multi-class classification also same thing, same procedure happens. First of all, bring the data, right? After that, first of all get the data. After that, what we have done here, look at this, right? So this is called build model, blob model, right? Here we are building the models. After that, you will see here model 4 equal to blob model, and then input features equal to number of features, right? And in this way you will see here create a loss and optimizer function. See, we have to create a loss and optimizer. Loss means exactly what is the difference between the way you are showing and the way they are calculating, right? So difference between the predictions, right? And if it is not clear to you, no problem, it will be clear in our next upcoming sessions, right? After that, you see here y log its, right? Y log its equal to model 4 and then x blob 10. This is how we predicted the probability, right? We predicted the probability, only inserting the data, right? And we are repeating the epochs, right? We have done it 100, and then I will just hit the enter button, and then you will see here, see how it worked, right? After that, you see the data is now shown into the image, right? And inside also you see there is a boundary line, right? So in this way we plan the data. We plan the data with, then we train test the data, right? And one lecture is for cleaning the data, right? So now after that, you see here train, test, and everything. After everything we plot the data. Okay, so today we will stop here, and on Monday we will see some other topics. And those who are new to this channel, then you know what I mean to say, subscribe the channel, right? And then so that you will get notification of upcoming bootcamp sessions, right?